Let me give you a brief overview on how was general relativity developed. So, special relativity was developed because Einstein didn't really like the idea of some special frame, because historically it was observed that when Maxwell's equation were transformed using Galilean transformation, they actually predicted some phenomena which was not observed in nature. So um, that means that there is some preferential frames for physics, which Einstein didn't like and also didn't make sense. And that actually led to special theory of relativity, which actually talked about inertial frames. But then Einstein again had this problem that this idea of ether that preferred a special frame, he never liked that, is also holding true for special relativity, because it was not really including gravity in it. So Einstein actually started thinking more about this, and his most brilliant idea, which he said that the happiest thought of my life, it came in 1907, and which we know now as equivalence principle. Which is understood as that uniform acceleration and homogeneous gravitation are equivalent. We might talk more about equivalence principle, but for now let's just accept this definition. Homogeneous gravitation, that's something to keep in mind for future, are equivalent. Now Einstein gave his theory of special relativity in 1905, so this is just 2 years after that. While the general theory of relativity actually came in complete picture somewhere in 1915. So what happened in these 8 years? So Einstein tried to use this equivalence principle, his idea, in many different ways to understand really what's really going on with gravity. And it took him all these 8 years to actually come to this conclusion that gravity, well, actually the first is that mass curves space-time curvature, and that's and gravity is not a force but an act of falling. And he arrived to this conclusion after a lot of work and frustration and time he invested in all this, and also he took help from many people. Um, and then actually it was concluded in Einstein's equation. We'll talk about that in the future. And in 1919, Eddington, along with his team, showed that actually the gravity actually bends light. This famous solar eclipse experiment. Actually, many newspapers ran headlines saying science has changed. Well, just fix the spelling. Okay. All right. So, so we will begin. Well, this is very concise. There's a lot which can be filled in, but the reason I sort of included this particular lesson is because I'm gonna start, and I would like to start with the idea here from equivalence principle and these three to cover the lessons in general relativity. We'll talk more in the following lecture.